Shuffle 46 is next. It is also a repeat LR. So to derive the permutation representation of this shuffle, we begin with our ordered packet 1 through 8, and we perform the shuffle. So since this is a repeat LR, we begin the same way as we would for any repeat LR. We simply deal the cards into a left and right pile. Now we pick up each half and deal those into a left and right pile. Okay, so this is called a repeat LR. Now the stacking is as follows. This is, of course, pile 1, 2, 3, 4. So the stacking is pile 4 goes on top of pile 2, pile 3 goes on top of pile 1, and then we'll stack the left pile on top of the right. So let's go ahead and do that. So pile 4 leaps over pile 3 and gets stacked on top of pile 2. Pile 3 leaps over pile 2 and gets stacked on top of pile 1. And then the left pile is stacked on top of the right pile. So what is the new ordering of the cards after that shuffle has been completed? Well, it's as follows. 4, 8, 3, 7, 2, 6, 1, 5. Cauchy's two-line notation for this permutation is as follows. The top row is always 1 through 8 for what we are doing. And the bottom row is 4, 8, 3, 7, 2, 6, 1, 5. Converting this to cycle notation, we obtain the following. 1 goes to 4, so there's an arrow from 1 to 4. 4 goes to 7, so there's an arrow from 4 to 7. 7 gets sent back to 1, so that completes this 3 cycle here. What about 2? What happens to 2? 2 gets sent to 8, so we have an arrow from 2 to 8. 8 goes to 5, so we have an arrow from 8 to 5. And 5 gets sent back to 2, which completes that 3 cycle. And then we see that we have a fixed point at 3. 3 gets sent to 3. So that means whatever begins in position 3 will end up in position 3 after the shuffle is complete. And also 6 is a fixed point. 6 gets sent to 6. So whatever begins in position 6 will be returned to position 6. Color coding our digits, we obtain the following. Recall that the color coding of our digits is as follows. Position values 1, 4, 6, 7 are color-coded black. Position values 2, 3, 5, 8 are color-coded red. This enables us to see what is happening with the fundamental structure of the sequence, since we are focusing on Bessey sequences here. And there are 2 possibilities. The Bessey sequence will be preserved in its current form, or it will be inverted. And inversion just means whatever cards began in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 once the shuffle is complete, and vice versa. The cards originally in positions 2, 3, 5, 8 get moved somewhere to positions 1, 4, 6, 7. So we see here that black 1 goes to black 4, which goes to black 7, which wraps around to black 1. Red 2 goes to red 8, which goes to red 5, which wraps around to red 2. Red 3 goes to itself. Black 6 goes to itself. So we can see that each value gets sent to a value of the same color. And so here we would say inversion does not occur. The Bessey sequence form will be preserved. And we can see that by using a Bessey sequence to demonstrate this. So let's begin with the Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0 and perform this shuffle. So this is a repeat LR. So you just do left, right, left, right. And then you perform that same set of actions on each half. And then we're stacking the 4th pile on top of the 2nd, so it leaps over the 3rd pile. The 3rd pile gets stacked on top of the 1st, so it leaps over the 2nd. And then finally, the left pile gets stacked on top of the right. So it should be the case that we still have 1, 0, 0, 1, 0, 1, 1, 0. And we do. Now, this doesn't mean that the cards have not moved around, because they have moved around, right? As we can see here, all of them have moved to new locations except for 2 of them. So we have cards in positions 1, 4, and 7. 1, 4, and 7. They're moving around among themselves. Similarly, for cards in position 2, 5, and 8, they're moving around among themselves according to these assignments here. Now, the card in position 3, this one right here, which happens to be a 0, that will be returned to its original location once this shuffle is complete. The same thing is true for the card in position 6, which is right here, that 1. After all of that mixing's done, that precise card will be returned to where it started, namely position 6. Taking a look at the shuffle diagram for shuffle 46, we see the following is true. We have our 2 fixed points, 3 and 6, so they don't go anywhere. And then we have our first 3 cycle. It's 1, 4, 7. So if we start at 1, we should expect an arrow from 1 to 4, which we have, an arrow from 4 up to 7, it's right there, and then we should have an arrow from 7 to 1, and that completes that 3 cycle. And we say that those 3 values, 1, 4, 7, constitute an orbit because they just cycle around among themselves. The second 3 cycle is 2, 8, 5. So if we begin at 2, we should expect to find an arrow from 2 to 8, which we do, an arrow from 8 down to 5, and then an arrow from 5 back up to 2. And that completes our second 3 cycle. And those 3 values, 2, 5, 8, constitute their own orbit. And I should point out that 3 constitutes its own orbit. It's a singleton set. And 6 does as well, since they are just assigned to themselves. They don't go anywhere. Now there is a note down here that shuffle 46 is the inverse of shuffle 1. Shuffle 1 is from the very beginning of this series. So let's remind you of shuffle 1. This is simply the LR shuffle on which we stack the left pile on top of the right. So this shuffle here is actually the inverse of shuffle 46. They will undo each other. And if you look at the actions for each of these shuffles, it is not at all clear that they should undo the effects of the other. So why don't we go ahead and just demonstrate that they are indeed inverses. At least we'll demonstrate one direction. So because shuffle 1 and shuffle 46 are inverses, if we perform them in either order, it should return this packet to its original order. So why don't we go ahead, we'll perform shuffle 1 first. So this is just an ordinary left-right shuffle on which we're stacking the left pile on top of the right. And we can even see the new ordering of the cards. It's a bit of a mess. Now apparently shuffle 46 is going to undo this mess and give us 1 through 8 back. Okay, so shuffle 46 once again is the one that we just did a moment ago. This is a repeat LR. So you do a left right, and now you perform the left right shuffle on each half like that and like this. And then the stacking for shuffle 46 is as follows. We stack the 4th pile on top of the 2nd, the 3rd pile on top of the 1st, and then we stack the left pile on top of the right. So apparently we should get back to the exact original ordering of cards, and we do. And it will also be the case if you perform shuffle 46 first, followed by shuffle 1, you'll get this same outcome. So those are truly inverses of one another. Now we can see their inverses by just looking at their shuffle diagrams, because their shuffle diagrams are identical except for the fact that the arrows are reversed. So for example, for shuffle 1, there's an arrow from 1 to 7. For shuffle 46, there is an arrow from 7 to 1. So it's just the opposite direction. So it's like they're undoing the effect of each other by having those arrows reversed and having the diagrams identical in every other way.